Hello everybody, welcome into another lesson. So today we are going to continue our discussion on slopes a little bit more. Now today we're going to talk about the relationship between two lines and their slopes. So here for the first example you have lines L and N. They are parallel to each other. So we're going to talk first about the slope and parallel lines. If you have the slope of the first line equal to the slope of the second line. So if the first slope equals exactly the second slope, so the slope of the first line equals the slope of the second line, they're parallel. Then that's how you could tell if the lines are parallel, if their slopes are equal to each other. Or on the other side of that, if the slopes are equal to each other, then the lines are parallel. That's a way you'll know if they're parallel. So that's pretty easy. What's a little harder is when they're perpendicular. So here we have lines L and N again. This time we have that line L is perpendicular to line N, which I suppose I should probably put a little right angle marker to denote it's perpendicular, right? So we have line L is perpendicular to line N. When you have two perpendicular lines, what is true about their slopes is that if you take the slope of the first line and you multiply it by the slope of the second line, you'll get -1 every time as the product. So if I take the slope of line L, multiply it by the slope of line N, I'll get -1. That's true every time for perpendicular lines. Another way to look at this as the slope of one line is equal to the negative reciprocal of the other line. That's a way to do it. If the slope is equal to the negative reciprocal of the other line, the negative reciprocal of the slope of the other line, that's how you can tell if they're perpendicular. Now, if you have lines that fit neither of these, if they're not equal and their products don't equal -1, then they intersect. There's just no other way about it. They just generally intersect. Of course, it's true perpendicular lines intersect, but they're a special relationship since they form a 90-degree angle. All other lines just intersect in general at some point. So we'll do a few examples here. This shouldn't be a terribly long lesson. This is a relatively pretty easy lesson here too. This won't be terrible. So we're going to throw up some slopes on the board here. I have about 8 examples here. So we're given the slope of the first line equals 3/4. We're given that the slope of the second line is equal to 12/16. What our job is here is to determine, are the two lines with these slopes, are they parallel to each other, perpendicular to each other, or neither? And if they're neither, they just intersect generally. So let's look at these here. So the slope of line 1, M1, is 3/4. The slope of line 2, M2, is 12/16. Like you can with fractions in general, you can always reduce them to simplest form. 3/4 is definitely in simplest form, right? But we definitely agree that we could reduce 12/16 to simplest form, right? They both have a common 4 between them, 12 and 16. If you divide both of those by 4, you actually get a slope of 3/4. Reduced to simplest terms, the slope of line 2 is also 3/4 like the slope of line 1 is. What do we observe? That the slope of line 1 equals the slope of line 2. Now, if the slopes are equal, what does that mean? The lines are parallel to each other. So that's going to mean that these two lines in this case actually run parallel to each other since the slopes are equal. And I got more examples here. Okay, what's next? So the slope of the first line equals 1. The slope of the second line equals -1. So in this case, we have two lines. The slope of the first line, m sub 1, is 1. The slope of the second line, m sub 2, equals -1. So what relationship do these lines have? Well, if you take the slope of 1 and 2, take those slopes together, right? So m sub 1 times m sub 2, what will you get? You'll get, of course, 1 times -1. That gives you a slope of -1. Now, if you get the product of those two slopes to be -1, what is true for those two lines? They are perpendicular. So in this case, the two lines here would be perpendicular to each other. In fact, I'm going to tell you something here. Here's a trick. If the slopes don't equal each other, if you've reduced fractions to simplest form and the slopes aren't equal, then it's clearly not parallel. The next thing you want to do if they're not equal then is go ahead and multiply your slopes. And if you get anything, and I mean anything other than -1, they're not perpendicular. If you get -1, they are perpendicular. If you get anything other than -1, then they're neither. They'd be neither parallel nor perpendicular. So there's a trick for you. And if you think about it, -1 is the negative reciprocal of +1, right? The negative reciprocal of 1 would be 1 over -1. So, or -1 over 1, which turns into -1. So clearly, then they're perpendicular. Okay. Now, here's something. What if I have the slope of one line equal to 3? I have the slope of the next line. In this case, it equals -3. So I have two lines here. The first line has a slope of 3. The second line has a slope of -3. Are they going to be parallel, perpendicular, or neither? Well, it's clear to see that 3 doesn't equal -3, right? So they're definitely not parallel. But when in doubt, multiply them out. So take the slope of the first line times the slope of the second line. So you would end up having 3 times -3. Well, what is 3 times -3? -9. Well, the slopes aren't equal. The product does not equal -1, so what does that mean? They're neither. They're neither parallel nor perpendicular. That means they just intersect at some point. And of course, if lines aren't parallel, that means they intersect. Okay, so that one actually wasn't that bad. What about the next one? I got about 5 more exercises. So the slope of the first line equals -3/4. The slope of the second line equals +4/3. So we have two lines here where the first slope is -3/4. The second slope is +4/3. Clear to see they're definitely not the same. They're not equal to each other, right? So if they're not equal, we need to proceed to multiplying them. So we'll take the slope of the first line times the slope of the second line. So that's going to look like -3/4 times +4/3. Which, if you notice, yeah, the 4's cancel, the 3's cancel. You just get a product of -1. If the product of the slopes is -1, then what's true for the two lines? They're perpendicular. So these two particular lines are actually perpendicular to each other. All right, 4 more. We're almost there, folks. So the first line has a slope of +3. Second line has a slope of -1/3. So first line has a slope of 3, second line has a slope of negative 1/3. Well, they're not the same, right? We can definitely multiply the product of the two slopes then if they're not the same. If you take 3 times negative 1/3, you would in fact get negative 1. Or you can use the fact that negative 1/3 is clearly the negative reciprocal of positive 3, right? Either way, if you can clearly see one slope is the negative reciprocal of the other, or if you want to multiply the product of the slopes and get negative 1, either way is fine. But in either case, you'll get that the two lines are actually perpendicular to each other then. Alright, down to the last 3. We're getting there. So, what's next? They're trying to trick you with this one. The slope of the first line is negative 2/3. The slope of the second line is going to be 2 over negative 3. They're actually trying to trick you here a little bit. So the slope of the first line is negative 2/3. The slope of the second line is 2 over negative 3. Well, what's true for 2 over negative 3? It would actually, since you have the negative only in the denominator, you can move the negative to the numerator. You actually end up getting that the slope of the second line is in fact also negative 2/3. So now you see clearly that the slope of the first line is equal to the slope of the second line. And if they're equal, what does that mean? That the two lines are parallel to each other. So if the slopes are equal, that means that they are in fact parallel to each other. I just got 2 more problems, then we're done. Okay, what about the slope of the first line equals 0, the slope of the second line equals negative 1. So I have 2 lines. The slope of the first one is 0. Slope of the second one is negative 1. Well, they're clearly not equal, right? So if they're not equal, multiply the two slopes, which would give you 0 times negative 1, which just gives you a slope of 0, which would give you a product of 0. Well, they're definitely not equal, so they can't be parallel. You don't get a product of negative 1 for the two slopes, so they are neither parallel nor perpendicular. They would be neither. They just generally intersect somewhere. Okay, one more problem, then we're done. What if we had, oh, this will be easy. The slope of the first line is positive 5/6. The slope of the second line is positive 6/5. So the slope of the first line is positive 5/6. The slope of the second line is positive 6/5. Well, they're definitely not the same, so they can't be parallel. There goes that theory about them being parallel. They're definitely not parallel. Now, some of you, if you understand the reciprocal trick, you would be tempted to say these two lines are perpendicular, right? Here's the thing, though. Yes, it's true that 6/5 is the reciprocal of 5/6. That's absolutely true. But why aren't they perpendicular? Because in order for the other line to be perpendicular to the other line, for one line to be perpendicular to the other, it has to be the negative reciprocal of the first line. And you only have the positive reciprocal, not the negative reciprocal. So these are neither parallel nor perpendicular to each other, because yeah, you could take their products, but you would get positive 1. You would need to get a result of negative 1 for their products, and clearly you're only going to get positive 1, so these are neither parallel nor perpendicular to each other. They just generally intersect somewhere. So yeah, that's it for parallel and perpendicular lines. The next lesson we are actually going to talk about vectors, which personally to me are kind of cool. You'll get to see what vectors are all about in the coordinate geometry series. So I hope everybody has a good night. Take care.